Okay, now let me give some introducing about Ethernet protocol. The data link and physical layer are the territory of the local and wide area network. This means that when we discuss about these two layers, we are talking about the networks that are using them. As we see in these two chapters, we can have wired or wireless networks. In 1985, the Society Computer of IEEE started a project. It is called Project 802. It is to set standards to enable intercommunication among equipment from a variety of manufacturers. Project 802 does not seek to replace any part of the OSI model or TCP/IP protocol suite. Instead, it is a way of specifying functions of data link and physical layer of a major line protocols. The Ethernet line was developed in 1970s by David Boggs and Robert Metcalfe. Since then, it has gone through 4 generations. It is Standard Ethernet, Fast Ethernet, Gigabit Ethernet, and 10 Gigabit Ethernet.
Standard Ethernet. We refer to the original Ethernet technology with the data rate of 10 MB per second as the Standard Ethernet. Although most implementation have moved to the other technologies in the Ethernet evolution, but there are still some features in the Standard Ethernet that hasn't changed during the evolution. The characteristic of the Standard Ethernet is Ethernet frame, and it starts with preamble, SFD, destination address, source address, type, data encoding, and also CRC. Addressing. Each station on an Ethernet network such as PC, workstation, or printer has its own network interface card, also known as NIC. The NIC fits inside the station and provides the station with a link layer address. The Ethernet address is 6 bytes or 48 bits, normally written in a hexadecimal notation with a colon between the bytes. For example, 4A, 30, 10, 21, 10, 1A. Unicast and multicast addresses. To find the type of the addresses, we need to look at the second hexadecimal digit. If it is even, it is unicast. If it is odd, it is multicast. And if all the digits are Fs, it is broadcast. Implementation of Standard Ethernet. A LAN with a bus topology using a coaxial cable. B. A LAN with a star topology using a hub. Access method. Since the network that uses the Ethernet standard protocol is a broadcast network, we need to use an access method to control the access to the sharing medium. The Standard Ethernet chose CSMA/CD with one persistent method. Efficiency of a Standard Ethernet. The efficiency of Ethernet is defined as the ratio of the time used by a station to send data to the time the medium is occupied by this station. Implementation. The Standard Ethernet defines several implementations, but only 4 of them became popular in the 1980s. Summary of Standard Ethernet implementations. Implementation, medium length encoding. 10^5, Thick Cox, 500 meter, Manchester. 10^2, Thin Cox, 185 meter, Manchester. 10^T, 2 UTT, 100 meter, Manchester. 10^F, 2 fiber, 2000, Manchester. Changes in the standard. Before we discuss the higher rate Ethernet protocols, we need to discuss the changes that happened to the 10 megabit per second standard Ethernet. These changes actually opened the road to the evolution of the Ethernet to become compatible with other high data rate LANs. Sharing bandwidth, a network with and without bridging, collision domains, switch Ethernet, full duplex switch Ethernet.
In the 1990s, Ethernet made a big jump by increasing the transmission rate to 100 megabytes per second, and the new generation was called the fast Ethernet. The designers of the fast Ethernet needed to make it compatible with the standard Ethernet. The MAC sublayer was left unchanged, but the features of the standard Ethernet that depend on the transmission rate had to be changed. We remember that the proper operation of the CSMA or CD depends on the transmission rate, the minimum size of the frame, and the maximum network length. If we want to keep the minimum size of the frame, the maximum length of the network should be changed. In other words, if the minimum frame size is still 512 bits and it is transmitted 10 times faster, the collision needs to be detected 10 times sooner, which means the maximum length of the network should be 10 times shorter. To be able to handle 100 megabyte per second data rate, several changes need to be made at the physical layer.
Okay, now we will talk about gigabyte internet and 10 gigabyte internet. First, gigabyte internet. Gigabyte internet, also known as standard 802.3z. The goals were to upgrade the data to 1 gigabyte per hertz but keep the address length, the frame format, and the maximum and minimum frame length the same. It also has two distinctive approaches for media access, and it is half duplex and full duplex. Actually, we use full duplex more often. This is physical layer. Next, 10 gigabyte internet. 10 gigabyte internet, also known as standard 802.38e. Okay, this time, this internet evolution not use distinctive approaches for medium access, just like gigabyte internet. It only use full duplex. There are 4 implementations are the most common, and this is the summary: 10G base SR, 10G base LR, 10G base EW, 10G base X4.